Okay, homework 5, solving systems of equations by elimination, as well as applications for this stuff. So we are actually going to do number 2, just because number 1 is skipping too many of the steps, so I want to do one that does most of the steps here. All right, so number 2. Step number 1 for the elimination method is to line up the equations. Lining up the equation means the x's should be on top of the x's, the y's should be on top of the y's, and then on the opposite side of the equation, you should have the constants. So 1, 2, 3, 4, 5, 6. These ones are already lined up already. It's when you get to problems like 7 and 8 that you have to rearrange them, make sure they're in standard form and they're perfectly lined up. So step 1 doesn't get used a whole lot, but make sure that you are doing that if you need to. Step 2, multiply one or both equations by a number to result in a variable with the same coefficient. So we've got 2 options here. We have a 2x and a 2x. So we want to either keep those, we can keep those the exact same, or let's say, for instance, you really wanted to change the y's. So this you'd have a negative 9y and a negative 3y. So with this one, you could get them to both be 9s if you wanted to do it that way. All right, so these ones, we are going to take everything, let's say in this bottom one, we're going to multiply everything through by a negative, okay? So you want to actually distribute that negative sign because it's really hard to kind of keep everything straight in your head. So let's rewrite this. Okay, and then I'm going to distribute this negative, so I'll have a negative 2x, a positive 3y, and a positive 9. Okay, you can just leave it like that if you think you're like really, really good at doing these and you're not going to mess anything up. But in my experience, people tend to mess up at least one negative sign. So line them up like that. That was step 2. Number 3, add or subtract the equations to eliminate this variable. I'm going to say always stick with addition. You're probably going to make one sign error if you do subtraction, but your choice. So we add these together. When we add the x's, they end up canceling each other out. When we add the y's, we get a negative 6y. And then when we add these constants right here, the negative 51 and the positive 9, we end up with a negative 42. Okay, step 4, solve for the remaining variable. So my remaining variable is a y. I'm going to get the y by itself by dividing both sides of the equation by a negative 6. So divide the left by a negative 6, and the y is by itself. Divide the right by negative 6, and we end up with 7. Okay, so that's my first variable. Step 5 is the same as what we were doing yesterday. Substitute this answer into either original equation to find the other variable. And you can pick one. If you always want to do the top one, or you always want to do the one with the lowest numbers, whatever you prefer. The second equation has some easier numbers here, so I'm going to go with that. So 2x minus 3y, but in place of the y, I'm going to sub in the 7 that I just found, equals negative 9, and then you just simplify and solve that equation. So this ends up being 2x minus 21 equals a negative 9. I'm going to add that 21 over to the other side. So I have negative 9 plus 21, and that is going to give me a 12, and then divide both sides of that equation by 2, and I end up with x equals 6. Okay, so ordered pair. Every time, all of yesterday's stuff and all of today's stuff. And the order is important. Make sure you're always putting the x first and then the y. All right, so that is our first type. Our second type that we did in this section was our application problems. So we're going to do number 9 together. So we got a step-by-step for this too. All right, so step 1, define your variables. All right, so we're trying to figure out what are you solving for? What are the variables that we're going to be using? So let's read through. Store or mixed 8 pounds of peanuts and 5 pounds of M&Ms. This 13-pound mixture is sold. Second mixture, peanuts and M&Ms. That's what we're trying to figure out here. Find the cost per pound of the peanuts and M&Ms. Okay, so that's step 1. Pick variables, write them down. If you always want to do x and y, that's fine. I personally find it easier to do something that kind of matches with the context. Number 2, set up 2 equations using the information that's given. So, sentence number 1, a store owner mixed 8 pounds of peanuts and 5 pounds of M&Ms. This sold for $55.27. So 8 pounds of peanuts would be 8 pounds times the price of peanuts. So that'll give you the dollar amount, plus 5 pounds times the price of M&Ms, and again, that will give you a dollar amount, ends up equaling $55.27. So that's sentence number 1. The second mixture had 6 pounds of peanuts, 4 pounds of M&Ms. That sold for $42.70. So 6 pounds of peanuts times the price plus 4 pounds of M&Ms times the price equals $42.70. All right, and then step 3, solve the system using your method of choice. It really depends how the equations end up set up. This one is beautifully set up to do the elimination method. So we've got, these are lined right up on top of each other. So I'm going to do that. I'm going to multiply both of the equations to get something to nicely cancel out. So we could either multiply both of the variable p to get a positive 24 and a negative 24, or you could multiply these to get a positive 20 and a negative 20. So let's go with my first option. Let's make this top one into a positive 24p, and then let's make this bottom one into a negative 24p. That way the p's will eliminate. So let's multiply through. Again, I'm going to pull up my calculator to make sure that we've got some nice values to look at. So let's line this up again. I'm going to move it down here. So this first one will be 24p plus 15m, and I'm just pulling up the calculator for these decimals. So 3 times 55.27 is 165.81. And then this one, multiply everything through by a negative 4. So I have negative 24p. This will be a negative 16m equals, and then I'm going to multiply this by a negative 4. So negative 4 times 42.70, that is negative 170.80. Okay, so line them up. When I add all the terms together, combine everything up, the p's will end up canceling. Positive 15m, negative 16m ends up being a negative m, and let's combine these up. So I have the negative 170.80 already. Combine that with a positive 165.81. So that is negative 499. Okay, so we got that. Only thing left to do is to divide both sides by a negative 1 so that the m is by itself. So divide both sides, and we end up with m equals 499. I'm going to put a dollar sign there because we are talking about money here. Okay, so that is the price of the M&Ms. And then we're going to take that value and plug it into either one of the equations, and then we'll end up solving for the price of peanuts. Okay, so 499. Let's go with the lower equation just because it has slightly smaller numbers there. So in the second equation, in place of the m, I'm going to plug in 499. And then I can solve for p. Okay, so we've got 6p plus, if I do 4 times 499, I get 1996. Okay, so now we're trying to solve for p. So what I'm going to do is subtract that 1996 from both sides. When I do that, I get 6p by itself. And then I have 4270 minus 1996. That gives me 2274. And then to get p by itself, I would divide both sides of the equation by 6. So if I divide that number by 6, I end up with 379. And again, that would be a dollar amount. So these ones, when you're talking about the solution to an application problem like this, you don't really write it as an ordered pair. You want to just make sure you're being distinct about which variable is which.